This is the solution for a question covering the sublearning outcome of solving equilibrium at a point from Mechanics 1. This question showcases a cable system carrying a 500 Newton box with 3 cables joined at point Q. We have to find the tensions in the 2 cables along the lines AQ and BQ. The question also provides us with a global axis on the diagram which showcases the sense of positive force directions. To solve for these forces, we recall that at equilibrium, the sum of forces in the x and y directions should be equivalent to 0. We will consider the point Q and solve for equilibrium at this point. We have 3 forces acting at the point Q, with 500 newtons acting downward, while the tensions in the cables from Q to A and from Q to B both have x and y components. Starting with the summation of forces in the x direction, we can see from the diagram that in reference to our given global axis, tensile force in the x direction from Q to A is negative, while the force from Q to B is positive. Using the given angles, we can use a cosine trigonometric function for both forces in the x direction. Therefore, our equation is as follows. Negative TAQ times cosine 45 plus positive TBQ times cosine 60 is equal to 0. Simplifying the trigonometric functions, we get TAQ times square root of 2 over 2 is equal to TBQ times 1 over 2. Further simplifying this, we get TAQ times square root of 2 is equal to TBQ. We can now find the summation of forces in the y direction in order to eliminate one of these unknowns. In the y direction, we can find both vertical components of TAQ and TBQ using the sine function. Furthermore, both of these forces are acting in the upward direction and will therefore have a positive notation. In addition to this, the 500 Newton box creates a downward force upon the point Q and is negative. Our equation for the summation of forces in the y direction can be simplified by solving the trigonometric functions to get TAQ times square root of 2 over 2 plus TBQ times square root of 3 over 2, which is equal to 500. Referring back to our solution for the summation of forces in the x direction, we had TAQ times square root of 2 equals to TBQ. This can be substituted into our equation for the forces in the y direction to eliminate TBQ. TAQ can then be factored out to achieve this following equation. Isolating for TAQ, we have 500 divided by square root of 2 over 2 plus square root of 6 over 2, and simplifying this, we get the answer 259 newtons. TAQ equals to 259 newtons is the final solution for the first question, and this is the tensile force acting along the line AQ. TBQ can now be found by referring back to the solution from the summation of forces in the x direction. Now that TAQ has been found, it can be substituted into this expression. TAQ times the square root of 2 is equivalent to 259 times the square root of 2, which is equivalent to 366 newtons. This is the solution to our second question. Therefore, the tension force along line BQ is equal to 366 newtons. And as a result, we have now found the tensions in the 2 cables along the lines AQ and BQ to be 259 newtons and 366 newtons respectively.